Refraction of sound is one wave effect, right? One wave effect, right? You need to understand in detail, right? We have learned on about refraction of waves under the water waves, right? And it came to be learned for sound waves as well. Simply, refraction of sound waves is bending of the sound waves when sound traveling through air layers with different densities. Refraction of sound is the bending of sound waves when sound travels through air layers with different densities. That's the definition. And natural occurrence, natural phenomena where you will observe refraction of sound is a distant strain is well heard, is heard loudly, it is heard clearly during the night time, daytime. Okay, right. So I have drawn a small diagram to explain this further. So quickly I will start my explanation from this refraction, and then I will go forward to the next wave effect, which is reflection. Right? Now imagine there is a train, there is a person over here. This is daytime. During daytime, right? There is no difference in temperature. Right? No temperature difference, no big temperature difference, right? Throughout the air layers, you don't get a big temperature difference. That means you don't get a big density variation. During daytime, no much temperature density variation. No much density variation in the air layers. Right? There is no much density in the air layers, right? During the daytime. So during daytime, there is no much density variation in your air, right? So the sound that is produced at a train will travel like this. So can you see? Right? So usually the sound will travel in equal velocities. Right? There is no difference. There is no difference in the velocity of sound. It will travel in equal distance, in equal speed. Right? So there is no difference in this sound waves. Right? Nicely, it will travel like that. Alright, it will travel that direction also. Right? The sound waves will evenly travel in the daytime because there is no big temperature difference or density difference. Right? Because there is no big density difference in the air layers, right? The sound waves will travel evenly. But during the night time, what happened? During the night time, what happened to them? During the night time, there will be temperature differences existing between air layers, right? Because of the night time, right, and the cooling the different rate of cooling of the ground, right? It creates different temperatures in different air layers. So different temperatures in air layers will create different densities. Now what happened? When you have different density in the sense, so on the upper layers, there would be much warmer air, upper layers, warmer air, which means upper layers will have low density. And bottom layers are much colder, and colder means it is high density. When the density of air is low, velocity of sound through air is faster. And when the density is higher, velocity of sound is slow. Right. Now, if you look at the same diagram, now in this upper layer, so imagine this is daytime. So this is daytime, and for the night time, what happened? But for the night time, what happened is the sound waves in the upper layers. The sound waves in the upper layers is much faster. So that means when the mehari it will be like that. It will go like that. it will move like that. It will be moving like that. Sound layer, it will be like that. And the next layer below that would be less warmer than that, less density, and the speed will be much less faster. So that means when the may hurry, and the bottommost layer is very slow, very slow. So it is very slow. Could be something like that. Right? So if you complete this, can you see? When you complete this, can you see? Right? Right? The sound waves which were going like this during the night time, what happened is it has a kind of a curving down. It has a kind of a curving down. Now you can see the sound wave has a kind of a curvature, right? This moving of the sound waves has a kind of a bending. So this is what we understand as refraction of sound waves. Sound waves through air. So the sound waves, right, will travel like this. Upper airs are much more faster and below ones much more behind, right? The bottom point is, bottom air particle is at a behind the pace. Upper air particle is much faster. So because sound in upper layers are faster because of low density. Sound in bottommost layer is much slower because of high density. So likewise, can you see? In earlier case, yeah, they same. Yeah, this velocity and this velocity same. Yeah, this corner velocity is the same. Right? That is how it used to be. That is how we used to be. Make corner velocity same. But here, can you see? This is faster, this is slower. And this corner is faster, this corner is slower. This corner is faster, this corner is slower. So overall, what happened is you can see make it's evenly spreading, and this is kind of a bending. This is how we explain or scientifically explain how refraction of sound waves will take place.